So this is our last and final lab of the year. So today we're going to do experiment 16.1, determining a person's dominant side. And this is talking about how the PNS is the peripheral nervous system operates. The brain sends signals from the left hemisphere and it operates the right side of the body, and then the right hemisphere operates the left side of the body. And so we're going to determine a person's dominant side. So what we have is these articles, the scissors, paper, pencil, paper towel roll, and a ball with a hairy head. And so in this experiment, we're just going to see what is the dominant side of this person. So what we're going to do first is ask this person who's helping me, my husband, to cut a medium-sized circle out of the paper. And we're going to note which hand he uses to cut it. And then we're going to ask him to write the word hello in the center of the circle. And note the hand he uses to write the word hello. Ooh. Now I'm going to put the ball on the ground, and I want to see what foot he uses to kick the ball. Oh, interesting. Okay, left foot again, left side. And then we're going to, I'm going to drop a coin on the ground, and we're going to see which foot he uses to step on it. Okay, left foot. Okay, in this experiment, part 7, in experiment 16.1, we put the cup a short distance away, and I'm going to ask Kelly to look at the object through the paper towel tube. Okay, now take away the tube, and I want you to point to the object with both eyes open. Now I want you to close your right eye and say whether or not the finger is still pointing at the object.
It is not pointing at the object.
Now open the right eye and close your left eye. Or the opposite eye. Now, is your finger still pointing at the object?
It is.
Okay, so your right eye is your dominant eye. Okay, next I want you to put the cup onto the wall and put your ear up to it and see if you can hear something on there. Great, thanks. This next experiment is experiment 16.2, and we'll be discussing the autonomic nervous system. It's composed of two parts, the sympathetic division and the parasympathetic division. These two divisions are made up of completely different nerves, ganglia, and they counterbalance each other in many ways. Sympathetic might increase the rate and strength of the heartbeat and raise the blood pressure, while the parasympathetic may slow the heart rate and decrease the blood pressure. So what we're going to look at is one aspect of the sympathetic and parasympathetic division. So we're going to look at the pupil of the eye. First we're going to turn off the light, and we'll look at the mirror, and then we'll turn on the light and be watching my husband's pupil in the eye. So we'll turn off the light, and now we'll turn the light on. Okay, what you should have seen in this experiment is that your pupil got smaller when the light was turned on. And this happened because the eye's main function is to collect light. So light enters your eye through the pupil. The larger the pupil, the more light it allows into your eye. So when the surroundings are bright, the pupil needs to be small, so only a fraction of the incoming light actually gets into your eye. Otherwise, your eye would become overloaded with light. However, as the surroundings get darker, your eye needs to let in more light so it can get enough information to form an image of what you're viewing. Thus, it makes the pupil bigger so more light can come in. So that's the end of that experiment. Okay, in this experiment, we're doing the sense of smell and taste to see if the sense of smell and taste interact for a greater sensation. So this is our subject, Kelly. and we're gonna use these two things on the plate and see if she can distinguish between the two flavors with her nose pinched. So Kelly, if you'll pinch your nose. And we're gonna start here with this one. And, okay. Chew that one and tell me which one you think it is.
Onion.
Okay. And then I'll tell me this one.
Onion.
Okay. And this one.
Apple.
Okay. And the last one.
Apple.
Okay. Great. Now I want you to unpinch your nose. And actually I have to cut them up real quick. So this time we're gonna try it without the nose pinched and see if Kelly can determine what I'm giving her. Okay, ready? Okay, open. Got it? What's that one?
It is totally an apple.
Okay, and this one?
And it's an apple.
This one?
That must have been a really strong onion.
So the result of the sense of smell and sense of taste experiment was that when Kelly had her nose pinched, that she guessed correctly on the onion, but then she ate an apple and she called it an onion. And then she ate an apple and she called it an apple. And then she ate an apple and called it an onion. So anyway, she got 50% correct. And then when she had her nose unpinched, she got them all right, except for the onion. That was the one she laughed at because she realized afterward that it was an onion. So when we have our nose available while we're eating, see if we can smell, it makes the sense of taste much more vibrant. So we'll move on to the next one. All right, so this is going to be the lab for 16.4. This is called the human blind spot. I just wanted to start first with just saying that the rods and cones are the determiner of what our eyes will see. Let me just read this. So each, the rod and the cone, have up to 100 million molecules that are sensitive to light. The cones have molecules sensitive to 3 colors of light, while the rods have molecules sensitive only to light in general. The rods are highly sensitive to light and can react even to tiny amounts. So when there's little light, your eyes rely mostly on the rods of the retina to form the images. Where there is a reasonable amount of light, the cones play the most important role. So what we're going to determine in 16.4 is that, we realize that the optic nerve comes into the eye, at the back of the eye, and at that point, there are no rods and cones. And so we're going to show actually that there's a spot that does not have rods and cones on it. So Kelly is going to hold this piece of paper, and I'm going to have Kelly hold that up with her arm, hold it out, extend it out, close her left eye, and look at the dot, not the plus sign. And then you're going to pull the paper closer to your face and then tell me when you can't see the plus sign or what happens to the plus sign.
As I get closer, I can see the plus sign.
Okay, and then put it far away and you can't see it now?
Mm-hmm.
Okay. Now pick up the other piece of paper. And this one has 2 lines. They're a 1/4 inch line, 1.5 inch long, with 1/8 of an inch between them, and then a dot about 1 inch away. She's going to hold the paper out, arm's length. She's going to close her right eye and focus on the dot, and then pull the paper slowly toward her face. What happens to the rectangles?
Becomes one line.
Yeah, the rectangles become one line. So the plus sign disappeared on the first one as the paper moved toward the face and then reappeared. And then in the second paper, the lines converged as the paper moved closer, showing that there was a blind spot on the back of her eye. 16.5. This is the variation in touch sensitivity. And this is going to determine that not all parts of the body are equally sensitive. Some parts of the body are more sensitive to the touch than others. So we're going to determine where on Kelly's body the touch is most sensitive. Okay, so I'm going to touch 4 main parts on Kelly's body. I'm going to start with her fingers, then her palm, and then her arm, and then the back of her arm. And she's going to tell me if she senses 1 or 2, and you have to close your eyes so that you can't tell what I'm doing, 2 pencil leads.
2. 2. 2. 1. 1.
So we determined that there are more touch receptors in the hand than in the back of the arm or the arm. So anyway, what we conclude is that after having this subject, that we should have a deep appreciation for God, for all He's given us in His creation, from rock formation, of ourselves, to the grand design of our human body. Creation screams out that there is a creator. So Robert Boyle, the founder of modern chemistry, says, remember to give glory to the one who authored nature. So I've enjoyed the class with you all. Bye.